Good morning, SE student. This is Nabil Abdullah, your math teacher. I hope you're all safe. Miss you all. In this video, you are going to learn about numerical sequence. We are going to talk about how to represent a numerical sequence and how to determine its sense of variations. Let f of x equal x squared minus 2x plus 3. For x equal 0, f of 0 equal 3. For x equal 1, f of 1 equal 2. f of 2 equal 3. f of 3 equal 6. f of 4 equal 11. Then the series of numbers 3, 2, 3, 6, 11 is called a numerical sequence. Also, if we have a0 equal to and a1 is given in terms of a0, a1 equal to a0 squared minus 1, a2 is given in terms of a1 using the same pattern to a1 squared minus 1, similarly a3 equal to a2 squared minus 1, and so on. By calculation, we obtain that, of course, a0 equal to a1 equal 7, a2 equal 97, a3 equal 18,817, and so on. This series of numbers is also called a numerical sequence. This question is for you to solve. So a sequence is a function whose domain is a set of consecutive natural integers with no gaps. A numerical function that is defined on a part I of n, the set of natural integers, is called a numerical sequence. The usual notation f of n replaced by one of the notation un, vn, and eventually others. The function f is written as un. Remark: if un equal 2 over n minus 3, then n is strictly greater than 3. Then the domain of definition can be represented in three different ways. D equal the interval with two open bounds from 3 till plus infinity, or D equal from 4 till plus infinity. Here we can start by 4 because I'm working on the set of natural integers. There is no decimal points as 3.1 or 3.2. So if 3 is excluded, and we start from the term above 3, so which is 4. Or the third form, D equal the set of integers without the numbers 0, 1, 2, and 3. In the sequence 20, 24, 28, 32, 36, we can start labeling the terms of the sequence. The first term as u0, the second term u1, the third term u2, and the fifth term is u4. But what about the 50th term of the sequence? The 50th term of the sequence is denoted by u49. Why is that? Because we started by u0. But if the first term is labeled u1, then the 50th term is u50. Notation: the series of numbers 2, 5, 7, 9, 21, 34 in this order is called a numerical sequence, un, and we can represent the terms of the sequence using. If n belongs to the set of natural numbers directly, then we can start by u0, or we must start by u0. u0 is the first term 2, the second term u1, the third term u2 equal 7, and the fourth term u3 equal 9. But if n belongs to n star, which means the set of natural numbers without 0 or strictly greater than 0, so then we start by u1. So the first term is u1 equal 2, u2 equal 5, u3 equal 7. But if n belongs to the set of natural numbers and n is greater than or equal 5, then we start by labeling the terms by u5. Then u6, u7 equal 7, u8 equal 9, and so on. Determination of a sequence. We have three forms to determine or to represent a sequence. The first one, sequence defined by listing all the terms. And this is the first way to represent or to determine a sequence. We can write all the terms of the sequence. The second form, sequence defined explicitly. What do we mean by this? The sequence is given by, the sequence un is given in terms of n, as un equal 3n squared plus 2n minus 5. Similarly as the function f of x, which is equal 3x squared plus 2x minus 5. But the third form is the same as the previous example, when we have a1 in terms of a0 and a2 in terms of a1. This form, we call it sequence defined recursively. You notice that in the above example, we start by giving you the value of a0. A sequence is defined recursively if its formula is given as a relation between two general consecutive terms. In this case, the first term must be given, as I said before, as a 0 equal to in the previous example. The recursive form is un plus 1, an example of the recursive form, un plus 1 equal to un minus 6. Here we notice that un plus 1 is represented in terms of un. So, a recursive formula is written in such a way that in order to find any term in a sequence, you must know the previous term. In other words, to find the 12th term of a sequence, you would need to know the 11th term. Remark, a sequence un is also recurrent if its formula is given as a relation among three general consecutive terms. In this case, the first two terms must be given. We mean by this un plus 1 equal to un plus 1 plus 6 un minus 5. Here we notice that un plus 1 plus 2 is represented in terms of un plus 1 and un. Also, this question is for you to solve. Sense of variation of a sequence, exactly like the functions increasing, decreasing, constant, strictly increasing, strictly decreasing. We have three ways to determine the sense of variation of a numerical sequence. Given the sequence un is said to be increasing if and only if un plus 1 greater than or equal to un. In other words, un plus 1 minus un is greater than or equal to 0. Strictly increasing if and only if un plus 1 is strictly greater than un, or as I said before, un plus 1 strictly un plus 1 minus un is strictly greater than 0. Decreasing if and only if un plus 1 less than or equal un. Strictly decreasing if and only if un plus 1 strictly less than un. And monotonic if the function is strictly increasing or strictly decreasing over its domain of definition. Constant if un plus 1 equal un. Example, suppose that un plus 1 minus un equal to un plus 3 after simplification. Since n is a natural number, then n is positive, so 2n plus 3 is also positive. Then the function un plus 1 minus un is strictly greater than 0, so un plus 1 greater than un, and finally we can say that un is strictly increasing sequence. The second method is by using an auxiliary function, but in this case un is given in explicit form. If un is defined by example un equal to n plus 3 over n minus 2, then we can write in this we can write it in the form of f of x equal to x plus 3 over x minus 2. Hence we can determine its sense of variation over 2 plus infinity by using its derivative function f prime of x, which is equal to minus 7 over x minus 2 square, which is strictly less than 0 for every x belongs to 2 till plus infinity. Then f is strictly decreasing, therefore un is strictly decreasing for every natural integer n greater than 2. Also, this question is for you to solve. The third way to determine the sense of variation, if all the terms of the sequence are positive, we can use this way. Then we can use un plus 1 over un and we can compare it with 1. So if un plus 1 over un is strictly greater than 1, then un is strictly increasing. If 0 less than, strictly less than un plus 1 over un strictly less than 1, then un is strictly decreasing. And if un plus 1 over un equal 1, then un is constant. Example, I'm going to apply the three ways of determination the sense of variation of a sequence. Suppose that I have un equal 1 over n, and definitely n is strictly greater than 0 because n not equal to 0 and n is a natural number. Then for all the terms of the sequence, all the terms of this sequence are positive. Un plus 1 equal 1 over n plus 1, then we replace un plus 1 over un by in terms of n, so un plus 1 over un equal 1 and n plus 1 over n, which gives us n over n plus 1. Since n is less than n plus 1, then n over n plus 1 is less than 1. Then un is strictly decreasing for n greater than 0. The second method, we use un plus 1 minus un, which gives us that the answer is -1 over n into n plus 1, which is strictly less than 0. So un is also strictly decreasing. Third method, since un is given in explicit form, then we can use the auxiliary function f prime of x equal -1 over x squared. And we notice that this f prime of x is strictly less than 0, then f is strictly decreasing, therefore un is strictly decreasing. We notice that by using the three methods we obtain the same answer, that un is strictly decreasing. And that's all for today. Thank you.